fellow programmers. Today we're starting a React Native project. This is part 1 of the tutorial series. There's a lot we're going to learn in this project, including building cross-platform apps using Expo, implementing navigation in Expo, working with alerts and local storage, integrating AI for meal recommendations, and much more. The only prerequisite for this project is a basic understanding of React Native. Now, let me show you what I've built. On the home page, you can see all the statistics are now reset. So let's move to the meal page and begin setting up our profile. When we click on the Complete Profile Setup button, we will be prompted to fill in our basic information. We'll start with our basic details such as name, age, and gender. Once that's complete, we'll click on the Next button. For the physical statistics, we will enter our current weight and our height. After entering those values, we'll click on the Next button to proceed. On the activity level and goal screen, we will select our activity level and our primary fitness goal. When we scroll to the bottom of this screen, we can immediately see our target calories, which have been calculated based on all the information we just added. Let's click on the Next button. If you have any dietary preferences, you can add them here, and then you can click to complete the setup. Now that the basic profile is configured, we can click on Generate AI Recommendations. This is where the Gemini AI will come into play, coming up with a recommended diet plan tailored specifically for the user, based on the information we just uploaded and added. On the AI recommendation screen, we can see all the user's input information, along with a couple of meal options for breakfast, lunch, supper, and snacks. You'll also see the estimated nutrition profile and calorie count for each option. Now, when I click on the plus icon next to the breakfast option, I'll be able to select the specific meal the AI planned for me for breakfast. So I'm going to go with oatmeal with berries and almonds for breakfast. I will repeat the same process for lunch, and for that I will select Greek yogurt with honey and granola. For a snack, I will go with a smoothie bowl with banana and berries. And finally, for dinner, I will select whole grain toast with avocado and eggs. Ideally, you are supposed to be adding them as you consume them throughout the day. Now, going back to the home page, we can see that our statistics have updated for calories, protein, and carbs based on the meals we just selected. On the meals page, we can see we have all the options for breakfast, lunch, and all the rest of the meals set up here. The profile page shows the current static data for now, as the information is not currently coming from a local storage or a database, which is something you can work on later. Finally, on the settings page, we have the AI configuration, which is where we will store our Gemini AI API key. According to YouTube Analytics, most of you who watch my videos are not subscribed yet. Please consider subscribing and hitting the like button. I am excited to introduce my first software as a service project called iBuildThis. iBuildThis is built for developers who want to escape tutorial hell. Learning to code is just one piece of the puzzle. You need real projects with real teams. iBuildThis is about quality, hands-on projects. We have a couple of projects on the platform which have AI recommendations based on your interests and learning goals, which you inputted during onboarding. The projects are also categorized into different fields. We have web dev, mobile dev, AI and machine learning, and gaming. We have a couple of daily and weekly challenges you can have your hands on to practice and improve your coding skills. This project is one of the ones I built a couple of months ago, so I will click on it and build it with the help of iBuildThis. After joining the project, we set it up and then start building. On the task page, we can use AI to generate tasks, and if they're good, we assign them to ourselves. So I will assign a couple of tasks to myself and click on the Complete Setup button. Then we move to the project details page. On this page, we have the project progress, the tasks, and we can update the project settings, like the project timeline and other features. So let's add a new milestone to the project by clicking on the project settings button. On this modal, we add a title and due date for the timeline and save it. And we have it here. On the task page, we have all these statuses which you can drag to a different state based on the current task you're working on to keep track of your progress. Let's talk about challenges. On the challenges page, let's say I am interested in this challenge called longest substring without repeating characters, and choose to join this challenge using the join challenge button. Now upon joining, we are taken to the dashboard. On this dashboard, we can work on the challenge in real time with our inline code editor. If your code satisfies all the test cases, you can publish it for others to have a look or get inspired by your solution. Not only can you work on the coding challenges, but you can also work on the design challenges. These challenges give you access to code and allow you to see changes in real time, as you can see on the dashboard right now. You have the ability to toggle between the design you are building and what you have built so far. If you are satisfied with your solution, you hit the publish button and you are good to go. You can also save your code and continue later anytime you are ready. On the dashboard, we have the chat feature for projects that need more than 2 teams. Everyone gets the message, it broadcasts to everyone. On the project metrics section, we have your total projects, challenges, total activities, and contribution scores. This is a project that will genuinely change the way beginners and even professional software engineers enhance their skills. If this sounds amazing, kindly visit iBuildThis.com and start working on a project now. Follow us on socials, on Twitter, TikTok, and YouTube. Links are provided in the description. Now, we are about to install Expo. What exactly is Expo and what is it used for? For a long time, developers needed to learn either Swift or Kotlin or Java in order to build apps for iOS and Android respectively. This approach made scaling and testing new ideas quite expensive. You would have to learn a new language and build 2 separate apps, which not only consumes time but also resources, and not to mention how long it takes to learn these technologies. So Facebook came up with React Native, a framework to help JavaScript React developers pivot to building mobile apps easily and quickly with a small learning curve. And it's great because it can build both iOS and Android. Down the line, React Native still needed some small tweaks when using certain native components from both platforms. For example, if you want to access the gyroscope on iOS, you would typically need to access the iOS build file and write some configuration over there. So Expo came along and hid those abstractions, allowing developers to build on what truly matters. Expo is essentially a wrapper around React Native to help developers access native functionalities easily and make the entire developer experience smooth. So we will be installing Expo and using it for this app. Let's navigate to the official Expo documentation website. We will copy the quick install command and paste it inside our terminal. To quickly fire up the terminal, press Command plus tilde on a Mac or Control plus tilde on Windows. By the way, we are using Cursor AI for this project. The installer needs a project name, but I will simply enter a period or dot to run and install the app in our current AI Diet Planner directory. And now we will wait a while for this to get installed. After the installation is complete, we will run the command npm run iOS to fire up our simulator. If you have Android Studio installed, you would need to run the command to fire up the Android simulator instead. A link to videos that walk you through how to set up both the iOS and Android simulators will be added to the description. Now we have our iOS simulator opened up on the right side of the code editor, and this is the default component that runs when you have successfully installed the Expo client. Now let's take a moment to explore some of the crucial configuration files we get out of the box from Expo. Understanding these files is key to building and deploying a reliable app, starting off with the package.json file. This file is crucial as it defines our project. Here, we see the package name, which is currently set to food. The main entry point is specified as Expo router entry, which tells Expo where to begin the application's execution. The version is set to 1.0.0. Next, we have the scripts object, which contains all the useful commands we can run from our terminal. We have start to begin the Expo development server, reset project for cleanup, and platform-specific commands like Android, iOS, and web to run our application on those respective targets. Finally, lint is for checking our code quality against predefined standards. We also have the dependencies, which are the required external packages needed for Expo to run the application, such as React and Expo itself. We will be adding our own very soon. Next, let's explore the app.json file. This is where we configure our application's native properties and metadata. We have the name and slug, both set to food. The version is 1.0.0. The orientation is locked to portrait, which prevents the app from rotating to landscape. We have a path to our application icon inside the assets/images folder. The scheme is food, which is crucial for deep linking, allowing external links to open specific parts of our app. User interface style is set to automatic to respect the user's system preferences, and new Arch enabled is set to true to use React Native's latest architecture, which offers performance improvements. Under the iOS object, we explicitly state that the app supports tablet with a value of true. Below that, we have the plugins object, which contains the configuration for the splash screen. The splash screen is the first image or animation that shows up when the user opens the app. It's essential because it gives the application time to load all data and assets in the background, providing a smoother user experience. We can find the splash image path in the assets/images folder, and you can replace it with your app icon by just ensuring the correct path is loaded at the image property in the splash screen plugin configuration. All these configurations are important, but we aren't going to dive deep into every single one since they are less important for the core of this particular tutorial. Next, we are going to explore the tsconfig.json file. This file holds the TypeScript configuration for our project. It extends from expo/tsconfig.base, which gives us Expo's default recommended TypeScript settings right away. In the compiler options, we have strict set to true for rigorous type checking, which is highly recommended for robust applications. Then, we define custom paths. We are setting an alias at __ to point to the local directory /_. This is a great feature that simplifies imports by allowing us to use a shorter alias instead of long relative paths, like .. // The include array specifies which files TypeScript should check, including all .ts and .tsx files, as well as the Expo-specific type definitions. And then we have the expo.env.ts file. This file simply includes a reference to Expo's global types with a note that it should not be edited and should be in your git ignore. Now let's elaborate on the layout.tsx file in the main app directory. This is the root layout for our whole application, the entry point that wraps all other screens. We start by importing dark theme, default theme, and theme provider from @React Navigation Native. These are essential for handling light and dark mode styling consistently across our navigation stack. Next, we import the stack component from Expo router. We also bring in status bar from Expo status bar and import the necessary setup for React-native-reanimated. Finally, we import the custom use color scheme hook from @hooksUseColorScheme, which detects the user's system theme preference. Inside the return statement, we wrap everything in the theme provider. Its value prop checks if the color scheme is equal to dark using a ternary operator. If so, it uses dark theme, otherwise it uses default theme. Wrapping in the theme provider ensures all children components can access the current theme. Inside this, we wrap our code with a custom meal plan provider that's likely for global state management. We'll be implementing that soon. Within that, we render the stack component from Expo router. This manages our screen history and transitions. For navigation, we have the first stack.screen named tabs. We pass an options object to it, setting header shown to false. This is where our tab-based navigation will live, and we hide its header because the tab's layout will manage its own UI. The second stack.screen is for a modal. We set its options to define the presentation as modal and set the title to modal. Below the stack, we render the status bar component with the style prop set to auto. Setting it to auto makes the status bar text color adjust automatically based on the background color of the screen, respecting the system theme. Next is the tab layout, which is found inside the tabs directory. This file, layout.tsx, inside the tabs folder, is responsible for setting up the bottom tab bar navigation for all screens within the tabs group. It dictates which screens are accessible via the tabs, how the tabs look, and what options they have. On the simulator on the right, we can see we currently have two bottom navigation tabs, Home and Explore, which are the Expo router defaults. We are going to completely replace this with our own custom bottom navigation bar to achieve a unique and branded look. To do that, we will be creating a new file inside the components directory called custom bottom nav.tsx. We are going to need icons. So first we import ionicons from Expo vector icons. Now let's start coding our custom component. We'll begin by importing React from React. Then we import animated, style sheet, touchable opacity, and view from React Native. We include animated because we might want to add subtle animations to our tabs later. Next, we define a TypeScript interface for our navigation items called nav item. This interface ensures our navigation data is structured correctly. We'll give it an ID of type string, an icon, and active icon. Both string types for the icon names and a label of type string for the text. Then we define the props for our custom component with an interface called custom bottom nav props. this component will take items, which is an array of nav item. Active tab, a string to know which tab is currently selected. And on tab press, a function that takes an ID of type string and returns void. We also define optional styling props: background color, active background color, icon color, and active icon color, all of type string. Now, we'll define and export our functional component: custom bottom nav, we destructure all the props, setting default values for our styling props so the component has a nice, consistent look out of the box, even if the user doesn't pass in colors. The defaults are background color to white, active background color to a light pink color, icon color to a dark gray, and active icon color to an even darker gray. Inside the return statement, we'll start with a basic view container. Then, we will iterate over the items array using the .map method. For each item, we first declare a constant called isActive to check if the current item .id is equal to the active tab state. Inside the map, we return a touchable opacity component for each tab item. We use touchable opacity because it handles the press event and provides visual feedback. Inside the touchable, we render an animated .view, which is a wrapper to apply animations. And inside that, we place our Ionicorns component. Now, let's add the stylings for our navigation bar. We need to import style sheet from React Native, so make sure that's done at the top. We define a constant called styles and call stylesheet.create. First, we define the bottom nav style for the main container. We set flex direction to row to align items horizontally. We add vertical and horizontal padding. To give it a nice rounded look, we set border top left radius and border top right radius to 25. For a shadow effect, which is crucial for a navigation bar, we set the shadow color, shadow offset, shadow opacity and shadow radius for iOS. Finally, we add elevation of 10 for Android shadow support. Next is the nav item style, which is applied to each tab. We set flex to 1 to distribute space evenly across all tabs and center the content using align items and justify content set to center. Finally, the icon container style. We set padding and border radius to create a small rounded background for the icon when it's active. Then we define and export the actual navigation item data. This array is called nav_items. We define it as an array of our nav item type. The first item has ID of home, icon as home outline, active icon as home, and label as home. The second is meals with restaurant outline and restaurant for the icons and the label meals. Third is profile using person outline and person for the icons and the label profile. The last one is settings with settings outline and settings for the icons and the label settings. Now, back to the touchable opacity component inside our map. We will add the necessary props to make it functional. First, we set the key prop to item.id. Then, we apply the nav item style from our style sheet. We set the onPress handler to be an arrow function that calls the onTab press function we passed in, and we pass it the current item.id. This is how we signal to the parent component which tab was pressed. Finally, we set active opacity to 0.7 to give a slight visual feedback when pressed. In the animated.view component, we will add the style prop. We pass an array to the style prop. The first element is styles.icon container. The second is a conditional style. If is active is true, we set the background color to the active background color prop. Otherwise, we apply nothing. This gives the active tab its background color. In the Ionicons component, we set the props to dynamically change the icon and color based on the tab's active state. For the name prop, we use a ternary expression. If is active is true, we use item.activeIcon, the field icon. Otherwise, we use item.icon, the outlined icon. We add as any to both of these since the string type from our interface might not perfectly match the expected icon name type. The size is set to 24. The color is also set with a ternary expression. If is active is true, we use active icon color. Otherwise, we use icon color. And in the main view wrapper that contains the map, we are going to add the style prop. We pass an array, styles.bottom nav, and then an object where the background color is set to the background color prop we received. Now, let's go back to the layout.tsx file inside the tabs directory. We are going to import the custom bottom nav component we just created and also the nav_items array. Let's now get rid of everything inside the return statement and also all the states so we can have a clean area to write our custom layout. We are clearing out the default Expo router tab setup. First, we are going to create a state to manage which tab is currently active. We define active tab and its setter set. Active tab using the useState hook, initializing it to the string home. Remember, we first need to import useState from React. Next, we define the function that will handle the tab press event. We'll call it handle tab press. It takes a tab ID of type string and simply calls set active tab with that tab ID. This function will be passed to our custom navigation component. Then, we need a function to conditionally render the screen based on the active tab. This is how we switch the main content of the screen when a tab is pressed. Let's call it render screen. Inside, we use a switch statement on the active tab. For each case, we return a simple view component containing a text component with the corresponding screen name, home, meal, profile, or settings. If no case matches, the default case returns the home view. We need to import the view and text components from React-Native. In the return statement, we will have a main view wrapper. Inside that, we place a child view where we call the render screen function. This is the area that will show the screen content. Below that, we render our custom bottom nav component. We pass the items prop as nav_items. The active tab state, and the on tab press handler as handle tab press. On the simulator, we can see the home text on the screen, but it needs styles to make the layout fit and look well. So next, let's add the layout styles. We will create a styles component like we did in the custom bottom nav. We need to import style sheet from the React-Native component. The container style gives the main view flex of 1, so it takes up the entire screen and sets a light pink background color. The content style also gets flex of 1, so the screen content takes all available space above the navigation bar. So now back to the view components. In our return statement, we are going to add our newly created styles. we add styles.container to the parent view. And styles.content to the child view that holds the screen content. Now we can see our entire bottom navigation bar rendered beautifully and perfectly at the bottom. This is looking great. When we click on the tabs, the text at the top changes to Mail, Profile, and Settings, which confirms our custom tab logic is working. Now, let's work on the actual homepage component. In the tab directory, we will get rid of everything inside the index.tsx file and write our proper homepage component. We will set up a basic home screen component. We'll import view from React-Native and define a functional component called home. It will return a view with a text component inside that says home. We need to import the text component as well. Back to the layout.tsx file, we will import the home component and return it inside the switch statement for the home case instead of the generic placeholder we created earlier. We have a red underlined on the imported home component because we forgot to export it from the index.tsx file. This is a common mistake, so we go back to index.tsx and add export default home. Now back in the layout, we can see the text home correctly at the top of the home page on the simulator. Now let's gradually turn the home page into a complete, well-structured page and component. We're setting the foundation for all the data we'll load later from the context. We'll start by importing the necessary visual components and hooks. We type import ionicons from quote at expo/vector icons. We need ionicons for all the visual cues like progress, time, and user profile. Next, we import our React fundamentals. Import React. Use state from React. We're bringing in React itself and the use state hook for managing local component state. Now, we'll define our main component, the home screen. This component accepts an optional prop on navigate, which is a function that takes a tab of type string and returns void. We include this to allow navigation between the home and other main tabs like settings. Inside the component, we define a state variable, selected view, to manage whether the user is viewing daily or weekly metrics. Next, we define a reusable component called metric card. This component is vital for displaying any nutritional metric like calories or protein and showing progress against a target. It's a functional component that takes several props. Icon name of type string, a color of type string, a title of type string, and a value and target, both of type number. Inside the metric card, we first calculate the percentage completion of the target. We use a ternary operator to ensure we don't accidentally divide by 0. Const percentage equal sign target greater than 0. Divided by target multiplied by 100. We use math.min to cap the percentage at 100%, so the progress bar never visually overflows the card. Now for the card's return block, we start with the main view container for the card. We then add the is_target variable to check if the value is greater than the target. Inside, we have a small view to hold the icon. In this view, we place an unicorns component. We use the name prop, cast as any. The size is 20 and the color is white. Wrapping the icon in its own view is a common practice in React Native to easily apply background and border styling just to the icon area. Below the icon, we render a text component for the title, followed by a colon. Next, a text component displays the current value, followed by a slash and the target. We use a ternary operator here to conditionally append space kcal if the title is equal to calorie, or just g for grams otherwise. This handles unit consistency automatically. Finally, we have a view that will contain the visible progress bar track. After the main content view, we render a text component to show the calculated percentage completion. Rounded to the nearest whole number using dot to fixed open parenthesis, 0 close parenthesis, followed by a %sign. And we close with a final view that will hold our colored progress bar fill and then close the component definition. Now, we define a simple placeholder component for individual meals called meal card. It's a simple arrow function that takes a meal object of type any as a prop and returns some structure. Now, in the parent return block of the home screen, we'll start building the main page structure. We need to wrap everything in a safe area view. This is critical in React Native to ensure content doesn't get obscured by the device's notches or status bars. So, we'll start by calling for safe area view. Remember, we would need to import the safe area view component from React-Native. Inside that, we'll use a scroll view to ensure all content is scrollable. If it overflows the screen's height, our first inner view will represent the header. Inside, we have another view to group the date information and the profile icon, allowing us to align them horizontally. For the date display, we add an unicorns with the name set to time-outline, size 16, and color #666. This icon gives context to the date. Next to it, a text component displays the date, July 14th, 2025. Another icons with chevron hyphen down is added to visually suggest the date is selectable or expandable. Finally, a touchable opacity for the user's profile icon. We use touchable opacity because it's clickable and provides feedback when pressed, which is good UX. It contains an icons with person-outline, size 24, and color #333. The next view contains our greetings. The first text component says greetings there, and the second asks, are you eating healthy? The following view handles the conditional rendering for our metrics. It will either display the metric cards or a setup prompt based on whether the user has completed their profile. For now, we use a placeholder condition of true. So if the condition is true, we use a fragment, the empty angle brackets, to render our metric card components. This avoids adding unnecessary view nesting. We pass the props, icon as flame, color as a shade of yellow, title as calorie, value as 500, and target as 2100. These are placeholder values we'll replace with real context data later. If the condition is false, we render the profile setup prompt. This is a view containing an icons with person-add, a title text saying complete your profile, and a descriptive text block. Finally, we have a touchable opacity with an onPress handler that calls the onNavigate prop, passing the string meals to navigate to the Meals tab. Inside, a text component says go to Meals and Setup. The last major view contains the daily and weekly toggle buttons. This allows the user to switch the view scope. The first touchable opacity handles the daily view. Its onPress calls set selected view with the string daily. Inside, an icons uses calendar for the icon name. The color is conditionally set. If selected view is equal to daily, the color is dark, otherwise it's light. Then a text component says daily. The second touchable opacity handles weekly. Its onPress calls set selected view with the string weekly. The icons uses calendar-outline. Its color is conditionally set using the same logic as the daily button. Then a text component says weekly. Now let's start writing some styles for the index page. We'll create the styles object, and for this, we need to import style sheet from React Native. We define the container style, giving it a flex of 1 to take up the whole screen, and setting the background color to a light pink color. Let's scroll all the way up to the safe area view and apply styles.container to it. Next, we add the style for the header. This uses flex direction of row to align the date and profile icon side by side, justify content set to space hyphen between to push them to opposite ends, and align items set to center. We add inner padding to give it space. We scroll back to the scroll view component and add the prop show vertical scroll indicator set to false. This simply hides the scroll bar on the right to make the view cleaner. Inside, the first child view represents the header, and we add the styles.header style to it. Next, we add the styles for the date container and date text. The date container style uses flex direction of row and a gap of 10 to space the icon and text. The date text style sets a sensible font size and color. We apply these to the corresponding components in the header. Next, we define the styles for the greeting section. The greeting container style adds horizontal padding and a large margin bottom to space it from the metrics cards. The greeting text style sets the font properties for the opening greeting. We apply them to the greetings view and the first text component. Now, we are going to add the question text styles. We define it with a larger font size, a dark color, and a bold font weight to make it stand out. We apply this style to the second text inside the greetings view element. Now, back to the metric card, we are going to add a few styles to structure the metrics display correctly. Let's move to the styling section and add these properties. The metrics container uses flex direction of row, horizontal padding, a gap of 16 between cards, and a margin bottom. This sets up the horizontal flow of the cards. The metric card style sets flex to 1, so the cards take up equal space, a white background color, and padding. It also sets min height to ensure they maintain a consistent size even if data is missing. The metric icon style defines a fixed size, a border radius to make it circular, and uses justify content and align items set to center to perfectly center the icon within its circular background. The metric title and metric value styles are straightforward font definitions. The progress bar defines the track of the progress bar with a width of 100%, a fixed height, and a light gray background color. The progress fill style defines the colored fill of the bar with a height of 100%. Finally, percentage text sets the font style for the percentage number. Now let's go back to the components and apply these styles. We scroll all the way up to the metric card component definition. Alright, so in the main view of the metric card, we apply styles.metric card. For the inner view that wraps the icon, we apply an array of styles, styles.metric icon, and a dynamic style object, where the background color is set to the color prop. Using a style array lets us combine static styles with dynamic ones. We apply styles.metric title to the title text component and apply styles.metric value to the metric value text component. Now, let's add the progress bar styles. The view that holds the progress bar track gets styles.progressBar. Inside, for the progress fill view, we apply an array of styles, styles.progressFill, and a dynamic style object. This dynamic style sets the width using a template literal to the calculated percentage, followed by a percent sign. It also conditionally sets the background color to an orange color if its over target is true, or a green color otherwise. Finally, we apply the style for the percentage text. It's an array with styles.percentage text and a dynamic style object to conditionally set the color to orange if its over target is true, or green otherwise. Now, we apply the container style for the metrics component in the home screen main return block. We add styles.metrics container to the view that contains the metric cards. We copy the existing metric card and paste it twice inside the true block to verify the layout. Now we have 2 metric cards on the app. We'll leave it as 2 for now. Now, let's add the styles for the welcome message that appears if the user hasn't set up a profile yet. We define 5 new styles for this section, including styles for the title, description, and the button itself. Back to the welcome segment, inside the false block of the conditional rendering, we apply these styles to the parent view, the title text, the descriptive text, and the touchable opacity button and its inner text component. So when we change the conditional value to false, we will see this beautiful complete your profile section. We'll turn it back to true for now. Finally, let's scroll all the way down to the style section and add the styles for the toggle of daily and weekly views. We define 4 styles here. The toggle container style sets flex direction to row, adds padding and margins, sets the background color to white, and gives it a border radius and inner padding. This is the container for the 2 buttons. The toggle button style sets flex to 1, so the 2 buttons fill the container, uses flex direction of row, centers content, and gives it vertical padding and a border radius. Toggle button active is a simple style that sets a light pink background color for the active button. Toggle text and toggle text active control the text color based on the selected state. Now back to the view toggle section, we add styles.toggle container to the parent view. For the text components, we add a style array. The first element is styles.toggle text. The second element is a dynamic style object where the color is conditionally set based on whether selected view is equal to daily or weekly. In the touchable opacity for the daily view, we use a style array, styles.toggle button, and then conditionally apply styles.toggle button active if selected view is equal to daily. We apply the exact same logic to the weekly touchable opacity and its text component, substituting weekly for daily. And voila, we can see the toggle working nicely. The active toggle gets highlighted with this beautiful faded pink and vice versa. Next, we are going to work on the meal plan context. So we are going to create a new file called mealplancontext.tsx inside the component directory. Thanks for watching this far. That brings us to the end of part 1 of this tutorial. Don't forget to like, share, and subscribe, and stay tuned for part 2.